Hello, in this video I'm going to go over a OCR A-level question on vectors, relatively standard, involving geometrical reasoning, not much more than would be expected on GCSE, but that doesn't mean to say that students like these kind of questions. The only thing that really makes this question stand out as definitely an A-level question is that it's talking about the origin O and position vectors, which are terms that are not used at GCSE, but otherwise it's using things we should know from then. So it says find the vector BQ in terms of AB, and it defines a few things. It tells us that PQ P is on the point here somewhere, such that the OP is equal to and BP are in the ratio 3:1. So we know that OB, it tells us the position vector of B it defines that as B. We can therefore say that the position vector of P must be equal to 3/4 of B, and that PB is equal to 1/4 of B, because they're in the ratio 3:1. I don't think at A level we're going to get too mixed up with the ratios here, but I'll say anyway, we've got a number 3 there and a 1 there. That's the ratio 3:1, because it's basically 4 parts. 3 parts, from O to P, and the other part from P to B. Okay, so that's just getting us started. It's also told us that something's gone funny there. It's also told us that Q is the midpoint of BA. Now, I think what we're going to need to do is we're going to be using the triangle law to find out PQ, because that's what we want. Okay, but we're going to need to find the vector BA first. I think we're definitely going so that we can use the triangle rule on this. So let's do that. Again, we want to get the vector BA. That's just going to be equal to minus BO plus OA, but that's minus B plus OA, which is plus A. There we go. All right, so that's BA, and then we can use the triangle law on. I've just rubbed out my point, and hopefully we just rubbed out my point P, and so we want this vector here. Well, it's slightly misaligned there, isn't it? Here, we want that vector there, and so we can use the triangle law on that. That's PB plus BQ. So we've got the vector PQ is equal to the vector PB plus BQ. Now that's equal to PB we've got up ahead. That's just equal to 1/4 B. And BQ is equal to half of the above vector, is equal to half of BA. So that's half of minus B plus A. And we can just add those up and simplify. So that's going to give us minus 1/4 B plus 1/2 A. Okay, so that's the first part done. The second part does a bit more defining. It's saying that the line, this line here, is extended so that the point R, and then it defines the point R, which is basically this line produced. Produced just means drawn further. And then that's R there. Okay, so and it says that PQR is a straight line, so that's what we've got. And it says this bit is trying to help us for the next bit. So it says so that PR is some multiple of 2A minus B. Notice that 2A minus B is a multiple of that as well. It's in the same kind of ratios. So we're going to use the fact that PQ is parallel to QR, or collinear indeed, they're in the kind of same straight line. So we're going to use the fact that, or PR indeed as well, they're all parallel to each other. So we can say that PR is some multiple, some constant, times by PQ. Because they're going in the same direction. Now, I'm not going to use the term K because I suspect they're going to work out as a different number for constant. So I might just call it lambda. So go to for PR is equal to lambda times PQ. So that gives us PR is equal to lambda times by minus a quarter B plus a half A. Putting that over, kind of taking the quarter out of the bracket, swapping it around a bit, we can see that's lambda over 4 times by 2A minus B. So that shows what we need to show. PR is equal to some constant times by 2A minus B. I suppose I probably need to be a bit where lambda positive, where lambda constant. And K, where K is a constant here. It's not the same constant, in fact. It's actually K is equal to lambda. I don't think we need to write that here, but I'm going to anyway. Is equal to lambda over 4. So, okay, that's the second part of that, part B. So then we can do the main substantial part of what the question's getting at for part C. So we're coming on to the substantial part. So just rub that out about. Oh, let's just undo that. Again, that's better. Okay, so we are coming to a more substantial part of the question. Look, we've got an expression for PR, and the question is trying to help us here. And to get the ratio that they want, we're going to use the fact that OA and OR is basically some, let's note this, let's write in the proper colour. OR is some constant times by, is basically parallel to, is equal to OP plus PR. But the thing is also OR is some multiple, I'll call it mu times A if you like. It's some multiple of A because it's parallel, or it's got to be, it's in the same direction as OA. So OR can only have A in it in its representation, and that's what we're going to use because we can actually use the triangle rule on this. Okay, so OR is equal to OP plus PR. Use a triangle rule on that and get some expression which we can compare and use the fact that there can only be an A bit in the actual representation. So let's do that. So OR is equal to OP. So OP, as we've already seen all the way up here, is 3/4 B. And PR we've got in terms of K times 2A minus B. Okay, let's tidy that up a bit. 3/4 B plus 2KA minus KB. Let's write that and put the B out in brackets. It'll be easier to see. Let's bring the A to the front. So that's 2KA plus 3/4 minus KB. But here's the thing. As I say, we compare with this. We've got this and this. We know that, or the whole thing, we know that the B component has got to be equal to 0. So we have 3/4 minus k equals to 0. So that gives us k equals to 3/4. So that tells us we've got k is equal to 3/4. So that tells us that OR, which has no b component on this at all, is 2 times k. So that gives us OR is equal to 3/2 times OA, or A, 3/2A. So basically this distance here is going to go that much further again. Let's answer the question. It wants the ratio of OA to AR. Well, again, just don't get mixed up with our ratios. That's 2 there to 1. So the ratio must be 2 to 1. To 1. Okay, 2 to 1, like that. Okay, so because it's 3/2 times by AR. Okay, so just to get this in perspective, it might be worth now just actually that we proved a geometrical result that wherever these kind of, because remember this is drawn arbitrarily, O, B and A they've happened to be drawn there, but wherever they are with respect to the origin, this distance here is always twice this distance. And I was sufficiently curious enough to actually look at this up on GeoGebra. The question's done now, by the way, but we can look up on GeoGebra, and I'm going to do that now. And we can see this here. Look, this distance here is 2 to 1 of this distance here. And wherever we move the point A, and indeed we can also move the point B, we can see wherever the point A and B are relative to the origin, that let's move the vector there. Wherever A is, the OB is always twice BR on this here. Okay, so that's it. I think I might have swapped A and B around there, but it doesn't matter. Let's just check. Yes, I swapped A and B around from my diagram, but hopefully you got the point anyway. And that's the question done. Hope you found it useful. Bye.